Okay, so this video will give a briefing to the LDA experiment. So what you're doing in this experiment is you're first actually forming LDA, and I'll explain a little bit more about why you're doing that. But you're taking LDA, you're reacting with propanol piperidine to form an enolate, and then this enolate will then react with benzoyl chloride, and you'll get a nucleophilic substitution reaction. So the reason you're doing this experiment is you're using reagents that are quite sensitive. They react with water. They react at high temperatures. So you're practicing and learning how to do a reaction that requires high degrees of control in terms of keeping the reactions dry, and also having to run these reactions at a low temperature. So you've already had some experience of doing reactions under an atmosphere and using syringe and needles, which is what you do when you want to keep things dry. This experiment takes is even more sensitive than ones you've done before. So it's about being even more making sure you're being even more careful with keeping your reactions dry and how accurately you use syringes and needles. But also, what's new in this experiment is you're going to be doing a low temperature reaction at minus 78. So you will have done reactions that need to be cooled down at 0 degrees. This reaction is even more sensitive and needs to be performed at a much lower temperature. So when you mix LDA and your piperidine, you form an enolate at minus 78 degrees because the two reagents are very highly reactive together, and then after your enolate is formed, you can then add your benzoyl piperidine, and actually the enolate will then react at a higher temperature. You'll bring it back up to 0 degrees to do your substitution reactions. But forming your enolate at least, needs to be done at minus 78. So, in terms of doing this experiment, LDA is a very sensitive and reactive reagent, but also you don't actually buy or use this reagent. You've got to make it first, and you prepare it from butyl lithium. So this is actually the first stage of your experiment. You're going to take diisopropylamine, react it with butyl lithium. Again, this is a really strong base pKa of 50. Okay, so very sensitive reagent, reacts really violently with water. So your reaction needs to be really dry. You react this with disopropylamine, and that will prepare your LDA base that you're going to use in this reaction. Okay, and so this is the reason where you really need to keep your reaction dry. If there's any water present, the butyl lithium will react with the water instead, and obviously then if you've got less butyl lithium forming your LDA that you need in your reaction, the yields in your reaction will be lower. So you mix sort of disopropylamine and butyl lithium at 0 degrees to form your LDA. Then you take your LDA that you prepared down to minus 78, and the sort of to make a minus 78 bath. What you do is you actually take solid carbon dioxide pellets, which sort of turns from a solid to a gas at minus 78 degrees. And then you have a solvent, either acetone or isopropanol. Okay, and that makes a bath of minus 78. So you cool your reaction mixture down in this sort of solid carbon dioxide, also known as dry ice, with acetone or isopropanol bath. And then you add your propanol piperidine to the reaction. The LDA and the propanol piperidine will mix together. They'll start forming your enolate at minus 78 degrees. And then after it's stirred for a period of time and formed the enolate, then you'll add the propanol piperidine and just gently warm the reaction up to 0 degrees. And that's where the enolate and the acid chloride will react together to form your final product. Okay, so as I mentioned before, butyl lithium LDA, very reactive reagents. They've got high pKa's, much higher than water, so they will react with water if there's any present and they've got the chance to do so. And if you can see here, this is exactly how butyl lithium will react with water. So you can see here, instead of it being a base and taking the proton from diethylamine, it will take the proton from water instead. And the result of that means you'll get lower yields in your reaction. So do make sure your reaction is dry, the glassware's dry, under a nice inert atmosphere of nitrogen. Make sure you're being very careful in how you handle and use the syringes and needles. You don't want these reagents to be mixing with the air, otherwise it'll just react with the moisture in the air and degrade. So as part of the pre-lab videos, again, the links to the videos of how to keep your reactions dry, how to use syringes and needles, and do take a look at these again to make sure that when you do the experiment, you do them carefully. And again, the instructions will also show you what to do as well in terms of how to set up your reaction. So you got a positive pressure of nitrogen under here, and then an outlet needle for the nitrogen to escape. And that means that this nitrogen atmosphere is dry, it has no water, so there should be no water present in your reaction mixture. And then by using syringes and needles as well, again, instead of opening bottles and having it exposed to the air, which contains moisture, which would react with your butyl lithium or other reagents, then you sort of withdraw it using a syringe, a needle, but also the instructions, the videos, how to use syringes and needles will show you how to make sure you expel all the moisture from your syringes and needles before actually mixing and taking up your reagents in the syringes. So top tips is to do look at those videos again. Do make sure you know exactly how to run reactions with under the inert atmosphere and using syringes and needles carefully to make sure you'll keep your reaction as dry as possible. Again, some safety precautions regarding syringes and needles. It's using syringes and needles are amongst the most common accidents that we have in the teaching laboratories. So do make sure you handle them carefully, you dispose of them in the correct place. They're not in the normal waste bins with the orange bags. These have to go in the special sharps bins that are usually out on the benches. Or you can move them into your fume hood as well if you want to handle them in there. And don't take the covers off the needles and try and put them back on after you've finished using them. This in particular is the most common way in which students have accidents. You try and put the cover back on, you miss, and then you sort of prick your fingers or your hands. So instead of doing that, you don't need to do that. Instead of doing that, just take the unsheathed needles and just stick them straight into the yellow sharps bin. Okay, so that covers the briefing of the LDA experiment.